Natural language processing, NLP, is a field of artificial intelligence that focuses on the interaction between computers and humans through natural language. The ultimate goal of NLP is to enable computers to understand, interpret, and generate human language in a way that is both meaningful and useful. This involves a range of tasks from speech recognition and sentiment analysis to language translation and question answering. NLP combines computational linguistics, rule-based modeling of human language, with statistical, machine learning, and deep learning models. Together, these technologies enable computers to process human language in the form of text or voice data and to understand its full meaning, complete with the speaker or writer's intent and sentiment. Language understanding is a critical component of NLP. It involves the ability of a model to comprehend the context, semantics, and nuances of human language. This is essential for applications such as chatbots, virtual assistants, and automated customer service systems. Effective language understanding allows these systems to provide accurate and relevant responses, improving user experience and satisfaction. Moreover, it enables more advanced functionalities, like summarizing long documents, extracting key information, and even generating creative content. As businesses and services increasingly rely on automated systems, the demand for robust language understanding models continues to grow. Despite significant advancements, language understanding remains a challenging task. Human language is inherently complex and ambiguous, with words and phrases often having multiple meanings depending on the context. Additionally, languages evolve over time, introducing new slang, idioms, and expressions. Cultural differences also play a role, as the same word or phrase can have different connotations in different regions. These factors make it difficult for models to accurately interpret and respond to human language. Furthermore, the need for large amounts of annotated data for training and the computational resources required for processing add to the complexity of developing effective language understanding models. Language models are the backbone of NLP applications. They are designed to understand and generate human language by predicting the probability of a sequence of words. Traditional language models, such as n-grams, rely on statistical methods to predict the next word in a sequence based on the previous words. However, these models have limitations in capturing long-range dependencies and context. Modern language models, such as those based on neural networks, have significantly improved language understanding capabilities. Models like BERT, GPT-3, and T5 leverage deep learning techniques to capture complex patterns and relationships in language, enabling more accurate and context-aware predictions. Training a language model involves feeding it large amounts of text data and adjusting its parameters to minimize prediction errors. This process, known as supervised learning, requires annotated datasets where the correct output is provided for each input. The model learns to associate input features with the corresponding output, gradually improving its performance. Pre-training and fine-tuning are common strategies used in training modern language models. Pre-training involves training the model on a large, diverse corpus to learn general language patterns. Fine-tuning then adapts the pre-trained model to specific tasks or domains using smaller task-specific datasets. This approach allows for efficient and effective model training. Evaluating the performance of a language model is crucial to ensure its effectiveness in real-world applications. Common evaluation metrics include accuracy, precision, recall, and F1 score, which measure the model's ability to make correct predictions. Additionally, perplexity is used to assess how well a language model predicts a sample of text. Lower perplexity indicates better performance. Human evaluation is also important, as it provides insights into the model's ability to generate coherent and contextually appropriate responses. This involves having human judges rate the quality of the model's output based on criteria such as fluency, relevance, and informativeness. Combining quantitative and qualitative evaluations helps in comprehensively assessing a language model's performance. Optimizing the performance of a language understanding model involves several strategies. One approach is hyperparameter tuning, which involves adjusting the model's parameters, such as learning rate, batch size, and number of layers, to achieve better performance. Another strategy is data augmentation, which involves expanding the training dataset with additional examples to improve the model's generalization capabilities. Transfer learning is also commonly used, where a pre-trained model is fine-tuned on a specific task or domain. Additionally, techniques like regularization and dropout can help prevent overfitting, ensuring the model performs well on unseen data. Continuous monitoring and iterative improvements are essential to maintain and enhance model performance over time. Handling ambiguity and context is a significant challenge in language understanding. Ambiguity arises when a word or phrase has multiple meanings, while context refers to the surrounding text that influences the interpretation of a word or phrase. Advanced language models use techniques like attention mechanisms to focus on relevant parts of the input text, helping to disambiguate meanings based on context. Contextual embeddings, such as those generated by BERT, capture the meaning of a word in different contexts, improving the model's ability to understand nuanced language. Incorporating external knowledge sources, such as knowledge graphs, can also enhance the model's ability to handle ambiguity and provide more accurate interpretations. Language understanding models have a wide range of real-world applications. In customer service, chatbots and virtual assistants use these models to understand and respond to customer queries, providing instant support and improving customer satisfaction. In healthcare, language models assist in analyzing medical records, extracting relevant information, and even aiding in diagnosis. In finance, they are used for sentiment analysis to gauge market trends and make informed investment decisions. Additionally, language models are employed in content creation, enabling automated writing and summarization of articles. The versatility and effectiveness of language understanding models make them valuable tools across various industries. The development and deployment of language understanding models come with ethical considerations. One major concern is bias in the training data, which can lead to biased predictions and reinforce stereotypes. Ensuring diversity and fairness in the training data is crucial to mitigate this issue. Privacy is another important consideration, as language models often process sensitive information. Implementing robust data protection measures is essential to safeguard user privacy. Additionally, the potential misuse of language models, such as generating fake news or malicious content, poses ethical challenges. Developers must implement safeguards and establish guidelines to ensure responsible use of these technologies. The field of language understanding is rapidly evolving, with ongoing research and advancements. Future directions include developing more efficient models that require less computational power and training data, making them accessible to a broader range of users. Enhancing the interpretability of language models is another focus, enabling users to understand how and why a model makes certain predictions. Multilingual models that can understand and generate text in multiple languages are also a key area of development. Additionally, integrating language models with other AI technologies, such as computer vision and robotics, holds promise for creating more sophisticated and versatile AI systems. Optimizing a language understanding model is a complex but rewarding endeavor. It involves addressing challenges such as ambiguity, context, and bias, while leveraging advanced techniques like deep learning and transfer learning. The impact of effective language understanding models is far-reaching, with applications in customer service, healthcare, finance, and beyond. As the field continues to advance, the potential for these models to transform industries and improve human-computer interaction grows. By prioritizing ethical considerations and focusing on continuous improvement, developers can create powerful and responsible language understanding models that drive innovation and enhance user experiences.